Hello and welcome to the last lesson of week 3, and we're going to be looking at patterns, equations, and graphs in this lesson. By the end of this lesson, I'm going to hope that you can use tables, equations, and graphs to describe relationships and patterns. So patterns, they're in the world around us. They're everywhere. And that's kind of what has drawn mathematicians to these patterns. It's for mathematicians, they like to look and see what's going to happen next based on what they've seen in nature, like in the previous slide, in music. And when you figure it out, it's kind of a cool thing. So we're going to get started by looking at a random pattern. And if you look at this picture, the natural question, I hope that you come, is how many dots would be in the next image? So in the first image, we've got 4 dots. You can count that. In the second image, you may not see much of a pattern. Yes, I see yellow, I see green, and I see blue. Okay. Is there much of a pattern there? Maybe. You might have some ideas. As you go to the third image, you start to see a pattern developing, hopefully, multiple patterns. See if you can figure out how many dots are going to be in the next image. Go ahead and pause the video. Give it a shot. Okay. Hopefully you've done that. Now let's take a look at it. So again, we could count. The first image had 4 dots. The second image had 12 dots, and the third image had 24 dots. That may not have been enough right now to help you figure out how many dots would be in the fourth image. But if you look at this, what I saw was you have a yellow in the middle. In the first one, there was 1 green to the left and 1 green down. And then between the 2 greens, you had a blue. In the second image, I had 2 green to the left and 2 green down. And then I added a green to the top and a green to the right. And then between the 2 greens and these 2 greens, we filled in with 4 blue. In the third image, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. And again, we filled in between the greens with blues. So the fourth image would have 4 green to the left, 4 green down, 3 green to the right, and 3 green up. And then there would be 4 by 4, so 16 blue, and 3 by 3, so 9 blue on top. And you'd have an image like that. And if you counted that, you would get 40 dots. If I asked you how many would be in the 10th image, you could figure it out, but it probably wouldn't go quickly. You could take the time and figure it out. I'm not asking you to. Or you could do what mathematicians do. Is there a quicker way to figure this out? Well, let's take a look. Another way to display this information would be in the form of a table. In the first image, we had 4 dots. In the second image, 12. In the third, 24. And in the fourth, we had 40. And you see that table start to develop here. Another way you could show this relationship is through a graph, which you see here. And you can see that it's growing very quickly as the number of images goes up. And the final way, and the way that a lot of mathematicians try to get to, is an equation. Now, I would not expect you to come up with this equation. This is a challenging equation. We will not do anything like this. But it's to show you the point that an equation can make this much quicker. In the 10th image, I could put, where x is the number of images, I could put 10 in for 10 in for x, and figure out that there would be 220 dots in the final, or in the 10th image, much quicker. Now, one thing I do want you to see here is every equation we've done up until now has had 1 variable. This one has 2, an x and a y. It's a little more complex equation, but we will be using that quite a bit as we progress through the semester. And I want you to see how the relationship between x and y, you can see that in a graph. You know that a graph has an x coordinate and a y coordinate, or an x-axis and a y-axis. And the same thing in a table. It's got an x coordinate and a y coordinate. So we have 2 variable equations, and like 1 variable equations, we need to look for solutions. Well, the solution to an equation with 2 variables, x and y, is any ordered pair, which looks like that makes the equation true. If with a 1 variable equation, it was a single number that made that single variable true. So the two-variable equation, is 630 a solution to the equation y equals 5x? So what we're going to do is we're going to evaluate this. Now we look at this as an ordered pair where the first number is x and the second number is y. So we're going to put 6 in for x and 30 in for y. So put 30 in for y, I get 30 equals 5 times 6. Well, what's 5 times 6? That's 30. So we can conclude that yes, 630 is a solution to this equation. So in this video, we're looking for the relationships between patterns that we're seeing. We're just starting the way of algebraic thinking before we move on any further.